Here's the answer for day 2, problem 1. A polygon is graphed below. It is reflected over the line y equals negative x. Graph the image. So here we have our polygon. It's four-sided. And here we have the line y equals negative x. It's running downhill with a slope of -1. We want to reflect this onto the other side of the diagonal line. To do that, you move each vertex to its new location, moving straight towards the line of reflection. For example, if I pick this dot right here and I move straight towards the line of reflection, I have to move in a diagonal direction so that I'm crossing the line of reflection with a 90-degree angle. And then continue to the other side of the line of reflection the same distance to locate where that dot is. Here is J prime. Let's do the same thing with point T. I'm going to travel directly toward the line of reflection. Because the line of reflection is a diagonal line, when I travel towards it, I have to move diagonally. So one diagonal unit, and then half a diagonal unit. Let's continue in that same direction. Here's the half, and then here's the one diagonal unit. Here is where point T prime is located. Now point A. Point A is one diagonal unit from the line of reflection. So just continue in the same direction, right there. There's A prime. And finally, this dot here, is this an S up here? Let's move towards the dashed line diagonally. 1, 2, 3 diagonal units. Now just keep going. 1, 2, 3 diagonal units. Here is point S prime. Let's connect these dots together to create our four-sided shape. This is going to be the same shape as the original figure, but it is the reflection or mirror image of that original figure. Now question B, what are the coordinates of T prime? T prime is located here. We're asked for the coordinates. Right there in the center is the origin. So it's 2 to the right and 5 down. T prime is located at 2, -5. Now day 2, problem 2. Triangles are drawn and congruent parts are marked. For example, this loop here and this loop here tells us that this angle and this angle are congruent. This mark here and this mark here tells us that these distances are congruent. Now it's not marked, but because we have intersecting lines, this angle will be 90 degrees, just like this one. These are called vertical angles, and vertical angles are always congruent. Now, are the triangles congruent? Are they the same size and shape? We have some ways to tell, and our techniques were called side, 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 angle, side, and so on. So we need to see if our situation matches one of the 4 techniques that we studied. I'm going to focus my attention on one of the triangles and take a look at what information I have. We have an angle that has a mark in it. Then we have another angle that has a mark in it. And then we have a side that has a mark on it. So going around, angle, angle, side, that is one of our criteria. So we can answer this question, yes. We know for sure the triangles are congruent, and our reasoning is the angle, angle, side postulate. This was something that we had studied in an earlier activity this year.